Welcome everyone to the Azure Infrastructure Data Security webinar for ARMS SaaS. This is ARMS SaaS means software as a service. It is our hosting your ARMS system for you in the Microsoft Azure Government Cloud, where the ARMS team becomes your IT management team for the server infrastructure, data security, disaster recovery, business continuity, and all things related to server-side components of ARMS. The topics we are covering: the Microsoft Azure Government Cloud, the data protection, business continuity, disaster recovery, and as well intrusion prevention, protection and prevention. Azure Government Cloud, as we mentioned, as I read off to you without you being able to see anything, is isolated from the commercial available cloud. It is reserved only for U.S. government entities. It is data centers that are both physically and logically isolated from the commercial Azure cloud. And it meets compliance with 35 to 40 different compliance policies, but among them, and the important ones are CGIS, CNSSI, DoD, FedRAMP, and FIPS. Glad everyone can see that now. Thanks, Josh, for not sharing your screen. Tenant isolation. ARMS SaaS is designed to isolate all the data and servers provisioned to a specific agency in a separate virtual environment. So what this means is we use separate resource groups that include separate virtual machines, separate virtual network, and separate storage for each agency. Tenants are completely isolated from one or the other. There is no sharing of virtual computing environment when it comes to ARMS SaaS and how we implement in the Azure Government Cloud. The Azure platform in general uses a virtualized environment where workloads from different tenants run in isolation on shared physical servers. So physical server meaning the hardware that you can open your eyes and see sitting there, and it runs these workloads coming from these virtual servers, and all of the virtual servers are your different tenants. So while they all run from the same physical host, the virtual environments and the physical host servers have no communication with each other as created by the Azure government environment. This helps to keep that isolation and data privacy in place. Customer instances operate as a standalone virtual machine that can neither reach out to hard drive or operating system of the physical host and vice versa. Tenant isolation in a resource group. In Azure, you have a resource group, and then you have the resources within that resource group. And so a resource group would contain only your agency's infrastructure, only your agency's resources. Examples of those resources are the virtual network, the virtual network interface, or NIC card, the virtual server, as well as the Microsoft SQL Server database. Resources inside of a resource group are isolated from interacting with resources located in another resource group, meaning your resources do not interact with resources in a resource group that belong to an agency in your state or in another state. Conversely, resources in your their resource group cannot call on your resources. We keep things isolated. That is the equivalent of saying it is not a shared tenancy. It is a single tenant occupancy. Data location, one of our next topics under data protection. Primary region. Azure is made up of what they call regions. Think of those as a state, if you will. Primary region is where your data lives and resides and used in production use. Azure government regions are geographic areas of the U.S. where multiple physically separated Azure Gov data centers exist, and they continuously replicate one another. In Azure Gov, every region has at least 2 physically separated data centers. Example, in Texas, they have data centers, 2 or 3, in Austin, Texas. They also have them in San Antonio, and I believe in Houston. So there's at least 2 physically separated, meaning separated on the map. They have redundant power supplies, different power sources, different internet sources, and things like that, so that one data center is not operating from the same power and internet and so forth as the next data center. They are brick and mortar, separated on the map, so they have all kind of redundancies in place between them. And then inside of a single data center, there are at least 3 physical servers running continuous replication of the ARMS SaaS environment. So in a region, we have at least 2 data centers, and inside of each data center is at least 3 servers that replicate and have this. So we would have at least 6 instances, at a minimum, 6 instances of replicated copies of your Azure infrastructure for ARMS SaaS. So if you're an existing ARMS SaaS customer, that's what we have just inside of one region at a minimum. If you're looking to become an ARMS SaaS customer, you can see how moving to the hosted model with us exponentially increases the number of servers that are used in replicating the data and providing uptime and backup and recovery. The secondary region. As part of our business continuity and disaster recovery strategy with ARMS SaaS, we replicate the agency's data to a secondary Azure Gov region. So an example, primary region, US Gov Texas. Inside of US Gov Texas is at least 2 data centers. We know there are more, but Microsoft tells us it's at least 2. And inside of each of the data centers, there is at least 3 host servers that are replicating for us. Secondary region, US Gov Virginia. The same minimum 2 data centers with minimum 3 hosts per data center exists in the secondary region. There's continuous replication between the primary and the secondary region. The secondary region has the same servers count, data centers count, as we mentioned. So doing the math here with a gimmick equation, ARMS SaaS equals, at a minimum, 4 data centers and 12 physical host servers. This diagram shows you what the outlay is of Azure with the primary region and the secondary region. On the left-hand side, we have the primary. On the right-hand side, we have the secondary. Inside of the primary region is your agency's resource group, and within all the dotted lines, that resource group are all the resources, such as virtual machines, storage, operating system and data disk, backup, private IPs, the virtual network, even VPN gateway, and IP addresses. As these are created in the primary region and put into play for your ARMS SaaS environment, a replicated copy of all of those, however, it'd be a new public IP address, is created, and it continuous replication. We take snapshots very often and push that over, and this gives us kind of a very hot failover capability if needed for disaster recovery and for business continuity purposes. It is not a matter of taking the latest thumb drive and restoring a data file, if you will. Much more technologically advanced than that. Data protection, encrypting data at rest. All agency data is stored in an Azure storage account dedicated to your agency using FIPS 140-2 compliant AES 256-bit encryption. This includes backups of that data as well. When data is written to the storage account, by default, the storage account encrypts everything that goes there. So it doesn't matter if I put a Word document there or if I put a SQL database there. If it goes into that storage account, it is encrypted. The encryption cannot be disabled it is secured as it rests there and it's not in use. It's not being trafficked back and forth from the server to workstation and so forth. This is managed intelligently by the Azure platform, the encryption keys for what signs the encryption and places this data at rest. So it's not a human. There's not an end-to-end employee that does this. There is not a Microsoft employee that does this. It's programmatic, and it's outside of the viewing of persons working at the data center, and it's outside of the viewing of us at ARMS, because we choose to use the platform-generated encryption keys to ensure that we have known capabilities to unencrypt your data. So the Azure platform is the see-all, know-all about the encryption of and the keys, which is used to protect your data at rest. Encrypting data in transit. This is where the ARMS system and personnel do provide some efforts to protect your data. The ARMS application has this same 256-bit AES encryption, but we have built the communication channels in ARMS to leverage that encrypted data and pass it through encrypted channels of ARMS, and to take that securely from the cloud server to the client, where it was decrypted by the client and displayed to the user. So we're using this at an application level. Now, there can certainly be additional network level encryption, such as VPNs, but we don't make that assumption that those may be in place all around the public safety office or anywhere else that you may choose, for example, a home or a hotel or something like that, where you might want to log into ARMS. So we implement application level 256-bit AES encryption. Notedly, this is FIPS 140-2 compliant encryption, so that is something that passes your CJIS security audit. The web application for ARMS works through HTTPS, what they call secure HTTP, with SSL certificate. Nowadays, it's TLS certificate to secure that traffic. That is no different than your online banking would use, or that the State Department of Public Safety uses on its own sites. So the review here, the ARMS desktop has application level encryption that's FIPS compliant. The ARMS web application uses SSL encryption, which again is FIPS compliant. And just looking at a diagram of this data protection, you see a laptop as an example of use of ARMS from a car, or a workstation use inside of the office. The workstation is using AES 256-bit encrypted TCP traffic, as well as HTTPS if you're using the browser version of ARMS from that workstation. The laptop in the car, or your smartphone, or your tablet, or your home computer, etc., would be using the same HTTPS traffic. And this traffic is not just directly going to the server. It first passes through what's called the Azure Application Gateway, which is a L7 load balancer, and part of its components is the Web App Firewall. Web App Firewall is used for intrusion protection and detection, monitoring that traffic, looking for bad actors, logging that bad actor information to then trigger other things to protect your data that occur inside of Azure Security Center. And so once it is passed through all of this intelligence to protect your data and keep your virtual environment secured, then it makes its way into the virtual network via the network security group, which is IP filtering and port filtering established for your agency, to the public IP, the network interface, and down to the server level. Keeping on with data in transit, some states require use of a VPN to connect to the cloud infrastructure. For example, Texas. Texas, any agency, no matter if they're connecting NCIC or not, those agencies are required to implement a VPN to the cloud server from where they're going to be using the CAD RMS client. Not all states do this. Only some require it. Some agencies just simply have that choice, make that choice themselves. The implementation for your ARMS SaaS environment can have a VPN if your agency chooses, and if your state demands it. Otherwise, if it's not a requirement, you still will pass the CJIS security policy audit with flying colors when not having the VPN in place, because the application level encryption is sufficient enough to pass that security audit. If we do put a VPN in place with you, it will be what's called an IKE v2 site-to-site VPN. That is a VPN established between our firewall in the cloud and your firewall on premise at your agency. Therefore, any workstation, tablet, so forth that communicates across the internet through your firewall would use connectivity to the cloud through this VPN tunnel. So you would have a layer of security on the traffic from the VPN tunnel, as well as an additional layer through the ARMS application level encryption as well. And this is a diagram of what this would look like with the VPN tunnel in place. We would have basically the client information. Instead of passing it directly through the web app firewall, this goes through what's called the Azure VPN, that site-to-site tunnel. And since it's VPN, it's connecting through that firewall, but directly to the VNet. It doesn't have to go through the application gateway of sorts, if you will. And it's able to connect directly to the virtual environment as if it was on the same private network. Business continuity and disaster recovery, what you will often see listed as BCDR for short. DR plan and disaster classification. ARMS SaaS has a documented disaster recovery plan in place, which includes disaster classification, plan of remedial actions, procedures of periodic testing, review, and revisions, procedures for emergency communication, incident tracking, and postmortems. The DR plan is based on potential disaster, probability of that occurring, and the impact it would have if it did occur. Example, an Azure region, let's say the Azure region, Texas. If for any reason there is a region-wide service disruption in the Azure Gov Texas region, the DR plan for ARMS SaaS puts that at a probability of 4 on a scale of 1 to 5, 5 being very low. We would call that probability 4. The impact of that would, on a scale of 1 to 5, we would call 3 being medium. Reason that isn't considered very high impact is because we have failovers in place to quickly have the agency up and running from a secondary region. So it's not a prolonged down period, therefore it's not considered impact of very high. It's not considered very low either. We put that at a medium classification for region-wide service disruption. And as we mentioned before, to help protect against the potential of an Azure region failure, meaning, and let's quantify that a little bit. Region failure is considered low on probability because inside of a region, there's at least 2 data centers that each run 3 copies, 3 physical hosts of the system for you. So for having a region-wide failure means at least the 2 data centers and at least 6 physical hosts are all down. They've all failed some way. Thanks to our use of our disaster recovery and business continuity plan, your infrastructure is continuously replicated to a secondary region. And that replication and failover to that happens according to the steps in our documented plan and in that time. It's usually about less than 1 hour to fail over to that once we've identified the need to fail over. So again, that would be an example of failing over from Texas to Virginia. Site recovery is what this failover is called. Azure Site Recovery means the secondary region's virtual infrastructure is replicated copy of the infrastructure from the primary region. So as we showed on the diagram earlier, everything from the left-hand box is continuously replicated to the right-hand box. The process of failing over becomes a matter of updating DNS records to tell it to use a different IP address to log you into your ARMS system. And that's a DNS record that our team manages, not your local team, so you don't have to worry about telling them to do that. Data replication across Azure government regions using Azure Site Recovery Service allows us to, 1, continuously replicate the entire infrastructure to the secondary region. 2, allows us to control when we want to fail over to a secondary region. That's beneficial because there may be an instance that we consider the region out of service, but Microsoft may not. And we don't want to wait around on Microsoft to make that decision. We would make that a lot faster than they would. So Azure Site Recovery gives us control as your server managers, not waiting on Microsoft. The third point, it allows us to control snapshot frequency and recovery point retention period. In our implementations, we make point-in-time snapshots every 2 hours, and we hold on to them for 24 hours. So again, this is very hot swappable, if you will. We get to perform periodic disaster recovery drills that do not affect live clients. We use non-production environments for that. And as mentioned, our process to fail over and to have the system back and going, update DNS records, and get system health checks in place takes no more than 1 hour. And most times it's 15 to 20 minutes to get back going from the failed over region. And at a maximum of data replication and these snapshots every 2 hours, you have a maximum 2-hour difference in data replication between the primary and the secondary. This 1 hour time to fail over and the 2-hour snapshot keeps us well within our RPO and RTO requirements and of any agency that we have seen as well that ask about those. RPO stands for Recovery Point Objective. RTO stands for Recovery Time Objective. Data backups and restoration plan. ARM SaaS uses Azure Backup. It's a service from Microsoft. It's called Azure Backup to periodically back up the entire infrastructure. So that means we are backing up the virtual machine, the VNet, and everything, the storage counts, whatnot. Backups are stored in the primary region in the Azure Gov cloud. And then we use geo-redundant storage for that, which means that those storage accounts are replicated across to the secondary region of Azure Gov and even the other regions of Azure Gov. To say it's geo-redundant is could be a tad misleading from Azure because commercial cloud Azure would replicate that around the globe. Since we are talking about Azure Gov, we're talking about 4 regions in the US. So don't confuse that to think that your data is now replicated to Botswana or Greenland or somewhere like that. It's geo-replicated, but it's in the 4 data centers in the continental US. In addition to the Azure Backup service for the entire infrastructure, we frequently run scheduled backups of the ARMS SQL database and the ARMS media directory as well. Storage of backup data uses encryption and isolation, just the same as we described earlier about the production data is both encrypted and isolated. Intrusion protection and prevention, IDS and IPS. Layers of protection. Microsoft Azure Government shares responsibility with the ARMS team to provide layers of protection to the agency's virtual environment. So the Microsoft side includes both physical and logical security of the data center and host equipment. Among those, the network access layer isolates the Azure private network from the internet. The Azure DDoS, IDS, meaning Dynamic Denial of Service, intrusion detection layer, provides prevention of denial of service and intrusion detection security for your virtual environment. Azure provides host firewalls and VLANs for their data centers, so their physical equipment is protected by firewalls. Thus, that adds a layer of scanning and security for bad actors coming into the physical equipment before it hits the virtual equipment. Azure enforces multi-factor authentication among its operators, meaning among its personnel at all of its data centers. So there will not be any instances of anyone trying to manage the data center equipment without having to authenticate just basically. They can't authenticate basically. It has to go through multi-factor authentication to do that. The ARMS team, on its end of the shared responsibility, its responsibility is to protect the agency's virtual infrastructure. So again, Microsoft is protecting the physical. ARMS team is protecting the virtual. The cloud access layer acts as a gateway from the internet into the isolated private network. We do that through load balancers, through the web app firewall, web app gateway, and various network address translation functionalities, what's called NAT functionalities. ARMS SaaS uses Azure Application Gateway, Azure Web App Firewall, and Azure Security Center at the cloud access layer. Security Center, think of that as like this huge, very intelligent virus and threat detection algorithm that is constantly improving. It's actually leaned upon by many different security systems around the globe. IBM and Sophos and such, those are constantly growing based off of what it learns from data analyzed through Azure Security Center. Virtual network layer, it's managed similar to an on-premise private network by our team. So inside the virtual network layer, there's the VM and its accompanied firewall, intrusion detection system, denial of service solutions, things like that. So not only are we using Security Center to protect the VNet, but it can also do some protecting of the objects within that VNet as well. Another object inside at the virtual network layer is called the network security groups. We use those to filter traffic based on separated NICs and or VPN gateways. So again, we can filter out your IPs and subnets to ensure that among all other things, everyone else that isn't on your network is denied service, whereas you are allowed service. Rendering a diagram of what this layers of protection looks like. At the top, we have this globe. It's the internet, and it's coming through the network access layer and the DDoS defense at the physical. Those are all at the physical layers, and that's performed by the hardware at the data center. Those are Microsoft responsibilities to keep bad actors out from the data center. And good actors are allowed to come through, and then cloud access layer is where our team begins to help secure your environment, where we are filtering that out from various things as bad SQL code, things that maybe do not originate from your network there at your offices, and so forth. And this is accomplished through Web Application Gateway, Web Application Firewall, Azure, and other Azure Security Center components that help to protect all the different resource objects inside of the VNet, including your virtual machines, virtual servers. Azure Application Gateway and Web App Firewall, WAF, Web App Firewall, is a feature of the Application Gateway that provides centralized protection of the ARMS SaaS instance from common exploits and vulnerabilities. WAF is based on rules from the OWASP, Open Web Application Security Project, its core set of rules 229 and 30. So basically those are standards. You'll see those on many different web-based application security audits. Web App Firewall helps to ensure those standards are met. Although there is the ARMS application level implemented protection from common attacks like SQL injection and so forth. The Web App Firewall provides additional layers of protections against SQL injection, cross-site scripting, HTTP request smuggling and splitting, remote file intrusion, meaning people trying malware, for example, trying to make its way onto a remote folder. Bots, crawlers, scanners, even bad code, for example, can be identified by the Web App Firewall. This is a drawing diagram of a Web App Gateway and Web App Firewall in place. So for example, cross-site scripting and SQL injection attacks are blocked at that layer before it ever makes it to into the VNet. Whereas valid requests, meaning it is clean code, it is originating from an IP address that we would allow, or originating through the VPN tunnel, those would be valid, and they can make their way into the virtual environment. Azure Security Center provides that central view of all the security, of all Azure resources and their state of security. Breakthroughs in quote-unquote big data and machine learning technologies are leveraged by Azure Security Center. They're used to analyze the events that occur across Microsoft's entire cloud fabric, whether that's commercial or whether that's government. And it goes into this big think tank that analyzes the commonalities, looks at history of events that occurred before, leading up to, and a history of events that occurred after when this common thing was identified, and then it uses its artificial intelligence, if you will, to say, okay, yep, this is a new threat. We need to pass this out, propagate this as policy out to all of our web app firewalls. And so it's not up to human to do that, although I'm sure they could upload some new code and configurations to improve Security Center. Security Center is designed to continuously make itself better, improve itself. The analytics of Security Center is integrated threat intelligence, again, looking for those bad actors at a global level of intelligence, applying known patterns for those malicious behaviors, and then detecting those using statistical profiling. Again, looking, what were the trends of events before and after, and was there any side effects to any host? So that's how it continuously uses traffic monitoring to improve itself. That is all for the slides. Now we would like to open the floor for anyone that might have questions.
All right, and if you do have a question, you should be able to move your mouse around on the screen and you'll see a participants button at the bottom. If you click on that, it'll open up a sidebar, and then you'll see a button at the bottom that says raise hand. If you click on that, it'll raise your hand and we can unmute you if you do have a question. If your mic is not working, you can always chat into the chat button that you'll find in the same place. And for that, if you do have a question in chat, go ahead and send the word question just so that we know that you are typing. All right. Looks like there are no questions. If you do have any questions, you can always reach out to us by calling 1-800-776-6783, or you can go to arms.com or email support@arms.com if you do have a question on anything that has to do with Azure infrastructure or anything with ARMS. Other than that, though, Josh, do you have anything else to add?
Nope.
Okay. All right. Well, everybody have a great rest of your day, and I hope everybody stays safe, and we will talk to you guys later.
Have a good one. Bye-bye.